And we're live. Welcome to Substrate Seminar, everyone. My name is Sasha Lansky. I'm developer advocate at Parity Technologies. And here today, I have with you Shelvin from Phala Network, who is the lead researcher at Phala. And today we're going to be talking about some very particular use case or a demonstration that Shelvin has prepared for us. So I'm particularly excited for him to demo. But before we get started, I just have a few things to mention for the community. And really the first is we are trying to secure our Stack Exchange page. And for that, we need your help. We need just about I think it's 18 members that have some a profile with Stack Exchange with enough backing such that they can commit and help us secure our page on Stack Exchange. So I'm going to post that link in the polls like I have done in the past few seminars, and hopefully there's some of you here today who haven't done that already and can help us do that. And the other announcement is that this is the second last seminar of the year. And we have something that I'm cooking up for the ultimate seminar of the year that's happening December 28th, and so stay tuned for that. Well, Shelvin, welcome. How are you doing today?
Yes, very good. And hello, Sasha, and hello, everyone.
Yeah. So tell us just a bit about yourself. So you're lead researcher at Phala. Maybe you want to go over what exactly you do.
Yes, and I'm the lead researcher of the Phala Network, and I helped to design our Phala blockchain, and also I'm the one of the writer of our white paper, and for now I'm also responsible for our development community development. So yes, actually we are of the same job, I think, and today I'm gonna introduce our just fat contract because as everyone may notice, Phala has been silent for a while because we are really busy about our underlying infrastructure and prepare for such great contract models. So I'm very excited and honored to have the chance to attend the seminar and introduce our work to everyone.
Awesome. Yeah, and so you will be talking about Ink, which is a smart contract language for WebAssembly smart contracts that I believe you are using in your Fat Contracts protocol. Is that correct?
Yes. And
So
actually,
a quick shout out to my colleagues on the Ink team because I think a team like yours, and this is why Substrate Seminars is so it's kind of fun, right? Because we get to see where there's collaboration between teams and efforts, and I think a team like yours especially is working closely or at least on the cutting edge of what the Ink team is doing. Maybe do you want to say a few words about that?
Yes, and actually, I think maybe Phala will be the first parachain of project who we just get the Ink contract running inside our off-chain workers. So it's actually maybe from your experience, you can use the Ink contract in the familiar way, just as before, but actually in the underlying mechanism is totally different. But actually, we are very glad to use the Ink as our programming language because actually we think Ink is a very mature programming language, and I think many developers are very familiar with it and they are very fond of it. So we think it will provide very good experience for them if they can just programming with their most familiar programming language for their smart contract, but still achieve some privacy, good performance, and other benefits from our contract.
Yeah, that's awesome. Well, I'm really excited to get right into what you have prepared for us today, and and see the demo that you've prepared. So without further ado, why don't you share your screen and I'll be in the back answering questions. If there's any questions that come up that are relevant to what you're showing, then I may interrupt you. But otherwise, just keep giving us what you've prepared, and I think a lot of us here are excited to see that.
Oh, sorry. Okay, so I think my screen should be clear, and
Yep,
okay,
crystal clear.
great. And hello everyone. I'm introducing myself again. I'm Xiaobin Zhou from Phala Network, and I'm the lead research of Phala Network. And today I'm going to introduce about our FAT contract. We think it's a very different smart contract model compared with all the existing smart contract model, especially for those like the Ethereum smart contract. And okay, today we're going to introduce the great feature of it, and also I'm going to present 2 demos for our contract usage. And also, I think after the such seminar, I think all of you can just visit our wiki or our workshop tutorial to just try our demos yourself. Okay, so let's get started. And actually, currently generally there are 2 ways to implement our contract, and I will introduce them separately. And actually, for now, to make the full usage of our contract features, you need to write something we call the native contract. That means you need to fork our code base, make some changes, and compile your own version of the Phala blockchain. And the advantage of this way is that you can make the full usage of all the great features of our contract, but it can be a little troublesome because you need to wait a long time for the compilation. And actually, I think in the previous Encode and Polkadot hackathon, most of our participants has already experienced such our FAT contract, and they have produced very interesting projects and implement very interesting functionality based on our contract. And the new thing I need to demonstrate today is our pink contract. Actually, we can see that it's a combination between the ink contract and our Phala network or our P runtime. And the great thing is that it can support unmodified ink contract, which you have already wrote. And actually, your ink contract will be executed in our secure workers and off-chain. So I think although it cannot fully utilize the great feature of our FAT contract, but actually for now, you can already experience some interesting point. For example, the improvement of the performance and the privacy nature of our contract. Okay, so I will first give an introduction of what the features of the FAT contract. I think the great part of the FAT contract is that actually the FAT contract is not the smart contract. It's more like the normal program, and the way we try to achieve this is that we run our FAT contract inside our TEE runtime instead of the substrate node. Actually, the things we do here is that we have decoupled the computation with the consensus. That means since our FAT contract is totally executed in the off-chain workers, that means its execution can be consistency. So actually, we don't need to wait for the interval of each block production process for the contract to execute. Instead, the FAT contract, it can just keep running in our off-chain workers. And actually, for Phala, we just used the substrate blockchain as the database or as the message queue. So we just do all the calculation and all the execution just in our off-chain workers. So in this picture, I just show the overall structure of the Phala blockchain. Actually, apart from the front-end SDK, for example, this can be used by our users to interact with the contract. For our backend, there are mainly 3 components. The first is the substrate node, and it is consists of the blockchain, and also we have the off-chain workers. And as I think as most of the people knows, our off-chain worker is based on the trusted hardwares, so it should preserve the integrity and the secrecy of all your privacy data. And also we have implemented a bridge called the ferry, which just connect the off-chain workers with the blockchain. So the workers can verify all the transactions and all the messages from the blockchain and do the execution just as instrumented. And since we just run our fact contract in the off-chain worker instead of during the block process, block production process, it brings a lot of the benefits. For example, for the existing Ethereum blockchain, actually the usual latency of each execution is about 12 seconds because you need to wait about 2 blocks for the execution to happen, and maybe you need to wait more blocks for the finalize of the block of the transactions. But actually, after we have enabled the execution in the off-chain workers, the latency, I mean the latency when you try to query the state or query some value inside the contract could be 0 because you are just directly interact with our workers, just like you are just query a server. So you don't need to wait for the block intervals. You just query the workers and you just directly get a result.
So, Shelvin, there's a question that came up that's pretty relevant, I think, for those that aren't too familiar about TEEs, trusted execution environments, and
Yes.
the context of having those in the runtime. Can you give a few words about that, please?
Yes, and actually, the TEE is when we say TEE, it actually refers to the underlying hardwares, because for example, there are many solutions from the different corporation. For example, as I think most of the people know, there is the Intel SGX, because so it's the trusted hardware which is based which Intel just hides some encrypto key inside the CPU, and all the encryption is based on the hardwares. So this is called this is when we say the TE, we refers to the hardware. But when we say the runtime, is that actually we just provide an execution context called the P runtime, and the P runtime is executed by the trusted hardwares, but it's provide necessary abstraction of all the computing resource you may need, and maybe some storage. And the important things the P runtime provides is it first isolates the execution context of each contract, and also it provides some necessary, which maybe for example the encryption and the decryption of all the data all the traffic which come in and out of the TEE. It's P runtime just responsible for all the encryption and the decryption, and all these things are opaque to the contract, and so the contract you don't need to care about this. So I think this is the difference between our P runtime and the TEE hardware.
Cool.
Yes.
Yeah, that makes sense.
Thank you. And then, okay, I think I can then continue. And another thing I need to talk, as we all know, that for example, in the Ethereum, although we have many workers, but actually the computing power of the host network did not scale to the number of the increasing number of the workers. That is because their execution pattern, for example, although there are maybe thousands of the workers in the network, but actually during each block production process, only one worker is selected by the consensus to do the real execution. And just all the other workers, they just do the duplicated execution. So actually, we can say that although their computation really confirmed the execution results, but most of the computing power is wasted in the previous contract. And I think some solutions, for example, like sharding, it can really mitigate such problem, but actually it cannot really solve the problem because you still need to handle the communication between different shards. And but actually in Phala, since our workers, they are based on the trusted hardwares. And then, and then I think a very important feature of the trusted hardware is that actually it's very hard to crack the hardware, especially remotely. to just crack the limitation of our P runtime and then attack the underlying hardwares, and can be really hard. So actually, we can think that the workers in Phala, each worker in Phala can be trusted. So we call them secure workers in our networks. So in the best case, actually no duplicated execution is ever needed, because all the workers all they can do, they cannot provide false results. They cannot manipulate all the results. All they can do is just that they can just faithfully do all the execution and provide the true results and reports to the network. So actually, in this way, we can say that the computing power of Phala is scalable. So with the increasing number of the workers, actually our computing powers can also increase. But actually, in the real world, we can also do some duplicated execution, maybe just for the safe, for the backup, and for such purpose. And I think this is the second features of our FAT contract. And also the third, the privacy. I think I won't explain much about this, because I think the privacy is one of the most important sell point of Phala in our early period. And this is I think the natural benefit brings with our solution based on the TE. And the last point, I think, and I think this can be the highlight of our FAT contract, because in our hackathon, we just see many developers just use these features to implement some very unique functions in their smart contract, which was thought not to be implemented in contract. That's the ability to access internet and do this in a safe way. This is because our FAT contract, just as I have presented, is executed in the off-chain workers. So the workers can delegate all the internet access requests for the contract deployers. And actually, if you try to access the internet with some secure method, for example, you send a HTTPS request instead of the raw HTTP request, which means which means you just establish a secure channel directly from inside the TE to a website, and all the contents between these two parties are encrypted and are safe. So actually all the data you just get from the internet service is witnessed by our blockchain. Because the response data will be uploaded to the blockchain first and then sent back to the contract. So there is no reversible operations. You cannot deny some request and some responsible data you have already received. Okay, and actually in the following demo, I will lay some emphasis on these features and show how to use this to implement some very previous thinking, very heavy functionality, for example, like the Oracle service. But with the ability to securely access the internet, actually such implementation can be really, really simple. Okay, I think this is some great features of our contract: the confidentiality, the scalable computing power, the low latency, and the internet accessibility. So such features make it very suitable, make our network very suitable to serve as the underlying computing cloud for the Web3 world, I think, because after all these just behind all these great features is that at its nature, our blockchain is a decentralized blockchain. So all the nodes they are permissionless. It's a permissionless blockchain which allows any workers to join. So I think the decentralized is very good, and also the things better is that the decentralized cloud can provide so many great features.
So Shelvin, there's that's not too clear on my end here. It's so I understand that the internet access sort of feature is that it enables like faster and more efficient sort of like requests, but I don't really understand what like more specifically how that's done, or how it differentiates the two traditional smart contracts. Can you maybe elaborate on that?
Yes, because for example, the traditional the most significant difference is that the traditional smart contract, they cannot access the internet service. So if they try, make it very expensive when they try to import some data outside the blockchain inside it. For example, the previous Oracle services like the Chainlink, all it's do is that it imports some information outside the blockchain, like the weather, like the price, like a lot of other things, like the time or other things, and it serves as a trusted base for all this information. And actually in our case, since your contract, you can directly access such service. You do not delegate such information to the service like the Chainlink, because you can do all the information requests in your own contract, just like you do in the normal program.
Got it. Cool. Yeah, that's super cool. That's kind of like you're kind of keeping everything within the runtime and adding more decentralization insofar as where that information is coming from and then how efficiently it can be accessed.
Yes, and actually this is gonna be my first demo, and
I'll let you take it from here.
Yes, and my first demo is about use our called the native contract. So to implement a BTC price bot with just a limited number of the line of codes, I think. Okay, and I will just show the progress, and then I think we can just walk through our code to see how this is achieved with our contract. Okay, a second. Yes. You can see my terminal, right?
Yeah. There's a lot going on the screen, so it's kind of hard to see what exactly is going on. So maybe
yes,
if you want to zoom in on something in particular, whatever you want to show us, maybe just choose that window and zoom in. Yeah.
Yes. And currently, actually, just as I said, there are 3 components for the Phala blockchain. So the first thing we need to do is run a local testnet, and just consists of the 3 components. And the first thing I got run is here. It's the Phala node, and it's just based on the substrate node. So yes, and I just got it running. And the second thing here is that we need to get our off-chain worker running. And actually, since I'm in China, there is some firewall here, so I need to give the worker a proxy for it to send the HTTP request here. Okay. And the third thing is to get the bridge between the off-chain workers and the blockchain running. So this thing we call the ferry. Okay, and after the bridge running, we can think what the bridge doing is that it keeps syncing all the block inside the workers, and it can also get some information. For example, some execution results inside the workers back to the blockchain and for the verifications. Okay, and now I'm gonna run our just some simple web page. Okay. And actually, all these things just running in my remote server. So I just do all the necessary ports forward here to my local host. So sorry. Yes. Oh. Okay, we're good. And actually, this is just a demonstration web page, and actually, it's just it provides some simple interaction with the embedded contract, some predefined contract. The first is called the guessing number. It's just easy, but actually, it's really confidential. So because it's running inside the TE worker, but I will not cover it today. We will just use our BTC price bot. Okay. Actually, since in Phala there are two kinds of the request we send to our contract. The first is called the query, and the second is called the command. The command is intends to change some states of the contract, and it has to be sent to the blockchain first, and then the workers will get the commands from the blockchain and do the execution. And actually, the query, just as I have explained, the query you can just directly send the query to the workers. So just through its RPC endpoint, so the query can be really fast, just real-time execution. And actually, both the commands and the queries are encrypted. So here we need to first sign a certificate, and this certificate is used to encrypt all the queries in all the following queries. So because if you have used the Phala the Polkadot extension, you will see that every time if you try to make some sign, and it will ask for your permission. But so we just do the certificate. So for example, in the following 15 minutes, you don't need to do all the signing work for your each query, because it can be really time consuming. Okay, it's a bot, and actually it's a Telegram bot. And actually, the first thing we need to do is that we need to set up our bot. There are two arguments. I think the first is the bot token, and the second is the chat ID. I won't explain much about this because it's all related to the Telegram bot. And we can, if you are interested, you can just read the documents for the Telegram bot, and you will see all these things it needs. And I think first, let me have a look. I can get the bot token. The bot token is used for the authentication the message from the bot. And also I need to input the chat ID, so the bot will know in which chat it will send the price, the current BTC price to me. Okay, and the setup. The click of the setup will trigger a send of the command, because actually we are changing the state of the contract. We change its arguments, and I will sign the transaction. Just wait for some blocks for the finalization. And actually, we can just do the query to any time, because for now it's still okay. So now we can see the bot token. We can got the bot token now. In previous, it's just empty, and now we can have the chat ID. Okay. And now we can require our bots to report the BTC price to us. Okay, our sign. It's another command to send. And now we can just wait for some time.
So Shelvin, just quick question. I'm curious about where the bot ID and the token that you're using from the Telegram API stuff, where is that persisting in storage?
All these data are persistence encrypted, and actually it's persistent on the blockchain, but it's encrypted by our period time. Oh, so yes, I have received the price. You can see here.
Awesome.
Because our contract it's just gets the price, and it reports the price to my Telegram bot. And this is the simple showcase, and then I will explain what is really happening inside it. So yes, I think Sacha, you have just asked a very good question, because actually all this data, although for now you can see the plain text, but actually you cannot see this data on the blockchain, even if you have synced all the data, because all these things are encrypted, and all the encryption key are safely kept in our secure workers. Okay, I can help everyone to go through the code.
Yeah, that would
sorry.
be super great. Yeah, I wanna understand and also help other people who are curious and kind of tinkering with this stuff understand
Yes,
what's happening under the hood.
yes, please. Actually, this is the source code of our contract, and actually it's available on our repository. So if you are interested, so you just go to our repository to read it. And I can help here. I can help everyone to go through it. I think first, this is the definition of all the states of our contract, and the first thing is the I should first mention that this contract is implemented as our native contract. So, but for now, you will not see the ink-related micro here, and you will see that in my next demonstration, I think, and but you are still welcome to play with it, but you need to change our code and register your contract here, and we have a tutorial for it. I will show it later. And the contract is called the BTC price bot, and actually it has four fields as it states. The first is the owner of the contract, and the last is the latest price of the BTC it has just received. And the bot token and chat ID I have just explained is about the Telegram bot, and I won't explain a lot about it. So the contract state is simple, and for each contract, actually, we need to define two kind of. Just I have the first is the command to it. We can have a look. The commands I think is relatively simple. The first is the set owner. We need to change the owner of our contract. The second is set up the bot. We just set up the token and chat ID for the bot, so the bot can correctly report all the current price to our Telegram accounts. And the third is this is very important. This is called report BTC price. This is trigger our contract to access the network service, and it will further send another HTTP request to report the price to our bot. Okay, let's go back. Okay, the second class of the request is called the query. So naming is a lot of maybe confusing, but actually here the request refers to the query, because the query when we see the query is directly sent to the workers, because you have just seen that I can send the query constantly and immediately get all the results. So this how we call it is of the 0 second latency is about. And actually, the query is just query all the states, each state of our bot. And I think a thing I need to mention here is that actually we can put necessary access control on each query, because we don't need to allow everyone to do the query. Actually, since all the query and the commands to our contract are just encrypted and signed, actually we can just verify the source of each query and the command and do the necessary access control based on their identity. Okay, and then we will go to the main part of our contract. For each contract, you need to define its ID, so to uniquely identify these contracts. And I think the most important part is the two functions. The first function is about handle commands. It's about how the contract will handle all the commands it's received. And the next is about the handle query, because we see the query can be relatively simple, because it's just return some value. But actually, like here, for example, we can check the identity of the sender to ensure that he is really qualified to see some sensitive data or not, or we can just return an error called "you are not authorized to read such sensitive data." Okay, there are many commands in my contract, but actually I will just go through the most important one, the report BTC price, because it contains the logics to access the network service. And I think actually each when you try to send the HTTP request, you just create a side task. In our case, for example, this is called the async side task, and the async side task, there is the main part of the task. For example, here, this is the main part of our task because it is designed what you will do in this task, and also there is two very important arguments: the block number and the duration. The block number means the during which time you expect the async task to happen. So for now, for example, I just get provided with the latest blockchain because a block number because I expect it to happen immediately. And another argument is the duration. And the duration determines when the side task will report the results it gets. For example, in this case, I gave the duration of 2 blocks, and in our testnet, each block takes 6 seconds, so two blocks will give it about 12 seconds to report the result. So after I have given these two arguments, actually all the life cycle of our side task is determined. It will just begin in the block number, and it will end in the height of the block number plus the duration. And after it has finished, it will report the necessary results to our blockchain. Okay, and let's concern about the main parts of our async task. The first thing to do here is it directly gets some the current BTC price from our web service. And actually, you can just use the HTTP request crates. For example, we use the surf here, and actually we use surf to read the latest price from this URL. And after it gets the results here, it will do the necessary parsing, and we can see it really gets the BTC price. Then it will send another request here to our Telegram bot to report the results. So I think this code can be really simple. So actually here, from the 170 to the 216, actually all this, and we can do just within just 50 line of code. What we do is that we get some BTC price from the web service and just send another HTTP request to report it to Telegram bot. And I think this can be really, really great since actually we are no more need to really depends on the heavy service like the Chainlink. You just do request all the data you need in your contract, and it can be really simple, just like normal programming with the Rust language. Okay, I think this is the main parts of my first demonstration, and I think I can try to answer some questions if you have. Well,
super interesting. Yeah. So for those rewatching this, there is a link to the code that we were just looking at. The BTC price spot source code. So I invite you to check that out. It's like super informative if you're curious on how this all works behind the hood. My question is, what sort of applications do you envision, like, or sort of like implementations of having the ability to pass in this Oracle, like this information that is being brought in on chain. Sort of right now, all that's happening is that we're using the Telegram API as just a bot. But what sort of interesting ideas do you have, like, beyond just this demo that you showed us?
Yes, and actually, we think the ability to access the internet can bring two parts of the functionality. The first is that it makes it more easy for you to try to import some data which is off chain, and to the blockchain. For example, the price and maybe other things. For example, our community member, which is called Josh, he during our hackathon, he just implements an auction bot for the remark NFT, and actually he just for example it use our HTTP request ability to read the information about NFT, about each NFT through the API provided by the remark officials. So we can see it's very it can be very easy. So you can get all the information you need for the auctions, just for the details of each NFT through our APIs. And I think this is the first part. And I think the second part is about with such abilities, it's possible to use our contract to connect many things, to connect many services. For example, to connect the data source with the bot, and to connect, I think, for example, the weather service to another things. And I think just we can use our best imaginations to how to use these things. And actually, I think at its nature, it's just to remove one of a very important limitation of the current smart contract, because for the first time you can just use our contract just as the normal program. You can just freely access all the web service you need.
Yeah, super cool. Definitely very powerful in the light of what you just said. Yeah, for sure. So you have a second part to your demo. I'm curious to learning more, I guess. Maybe we can just keep going. There's no questions for now, but I encourage everyone watching live to ask your questions. Just put it in the question box, and then we will be sure to answer them as they come.
Great. And my second demonstration is about the ink contract, and I will show because actually, although our native contract, it can be really powerful, but actually we think the deployment of the native contract can be really troublesome, and actually we just want to enable a free deployment, a very convenient deployment of the contract, just like all the previous smart contract does. So so this is the second demonstration about, we will show how to deploy the ink contract just through the, actually you don't need to change our code base, you just interact with our front end with our web page, and you can just upload your ink contract and interact with it. So this is my second demonstration is about. Okay, I first stopped my previous service. Oh, okay, I'll start. And okay, this is another instance. I just do all the compilation, so we don't need to wait for it. Also, I will still start all the components. The first, I will start the Phala node, and the second, the second is our off-chain workers, and the third bridge. Okay, now we have our backend running, and also this is another demonstration front end. Okay, great.
So where can we find this repo? Is it the workshop? It's you have a branch, I think, called workshop. Is that it? Yeah, I think so.
Yes, I will give the link in my PowerPoint, and I just yes, I think Han can do this for me.
Oh,
it's just share the link of our PowerPoint, so anyone can find the link.
And correct me if there you go. We sent it at the same time. Awesome.
Okay, look. Okay, this is another page, and sorry. So for now, this page is for the interaction of the contract, but we still need to do some, I think, some deployment of the contract, and I will show the full progress. So in this part, to deploy the contract, we still use the Polkadot.js, and actually in the future we will provide, I think, a better UI for people to interact with it. Okay, and the first thing I need to do is that I need to register a role called the gatekeeper. Actually, because in our network there is a special role called the gatekeeper, and the gatekeeper is responsible for all the key management work. So since we need to deployment the contract, we need to first register gatekeeper so he can just do all the key allocation for each contract, and so the contract contents can be safely encrypted. And we need a sudo. Since this is in our test, in a local test node, we can use the sudo to do the registration. But actually, when you are interact with our testnet, you don't need to care about such things because we will do all the setups for you. Okay, let's see.
So quick recap, because I think it's important to understand what's going on right now. You're on the Phala testnet, and can you just recap what exactly we went from setting up the backend on your local machine, and now we are on the testnet. Can you just clarify what you're trying to achieve here?
Yes, and I have just run a local testnet, and actually, so it's not a Phala testnet. It's my local testnet, so I need to do the extra setups, and so I have just got the network running, and after that, after the work running, since this is a development testnet, the first worker, I think only the only worker, it will first register itself as the workers, and then we will need to promote it to the gatekeeper, so he will do all the necessary key management work for us, so then we can deploy our contract so safely. Because
got it. It's confusing because you've named your chain already file development, and I'm always used to seeing localhost or some development node. But it's
okay.
Just to clarify for those watching, this is just the Polkadot.js apps UI interface for what's going on locally in Shelvin's local machine.
Okay, I will first do the gatekeeper registration work.
So the gatekeeper is sort of kind of like managing the access of or managing the registries of the different contracts.
Yes. Yes.
Does that sound correct? Okay, cool.
Yes, and actually, after you have deployed a contract, the gatekeeper will just allocate a contract key for you. But you cannot see it. All the keys are preserved inside the secure workers. But it will do the necessary key distribution for the workers to encrypt and decrypt the state of the contract. And after the execution, the key will be retrieved back. So actually, only the gatekeeper are allowed to process the key. And now we can see the gatekeeper has been registered. So now we can do some real work about the contract deployment. Okay. The first things we need to do. Oh no, we can switch back to the normal users. The first things we need to do is that we need to upload our code. Because in Phala, actually, we divided the contract instantiation process into two parts. The first part is to upload the code to the blockchain, and the second part is about instantiate it, to instantiate the code into a real contract instance. So the first thing is about upload the code, and I will just use this is the Flipper example from the ink contract, from the ink repository. So I think if you are an ink enthusiasm, so you should be very familiar with this. It's a Flipper It's the round flipper code, and we will first upload it to the blockchain.
So yeah, this is very similar to the ink tutorial that we actually have on our Dev Hub, where we're just uploading the contract code, which is it's a WASM blob. I mean, it's a WASM file.
Yes, and actually in the future we will try to provide a more user-friendly process for this. And actually we can see that from this event we can see that the code has already been uploaded and with an code hash. And now we can really deploy the contract. We can select the instantiate contract, and we will use the code. We use the WASM code we have just uploaded, and we will give it the necessary initial arguments. I will I will take a look at my cheat sheets because this is B4, B9, D1, B. Actually, this is a function selector for the default function, just like here, because yes, this is an ink constructor, and I just set the initial argument to let it call default function, so it will do all the initialization for us. Okay, there is a thought, but actually this is not met here. We can just give a 0 here, and finally, actually, we need to specify which worker we try to deploy our contract. So this can be very different from the previous deployment, because the contract is not public. Actually, it can only be its state can only be temporarily decrypted by the deploy worker you have specified. So for now, since we have only one worker in our network, we will just let him to do all the calculation. Okay, we need to wait a few seconds for the contract to be instantiated.
So is there anything happening in the logs and the terminals running behind that we can see? Particularly on
maybe slash
in the second one.
Here, actually, we can see the yes, the worker it has. Oh, sorry. Actually, many things has happened after our I think behind our operation. The first thing is that after you have upload the code and you have send the request for the instantiate, the gatekeeper will process such request. And what gatekeeper does is that it will generate a contract key for you, and such contract key will be used for all the following encryption of all the input data and the contract state to the workers. So actually, only the workers who has processed such contract key has the ability to really decrypt the contract. So actually, in our network, unless the gatekeeper is compromised, then I think all the contract secret will be leaked. So I think even one of the workers has been compromised, our network will still be good, because only the current contract key is processed will cause the leakage. Yes, and here and after the gatekeeper has generated the key, it will distribute the key to the workers you have specified, so the worker will do the real execution here. Okay.
Great.
Yes, and now I think we can try to interact with it. And the first thing we need to do is that we need to get the contract ID. Oh, sorry.
Is there like a graphic or something to help this kind of mental model of, off-chain worker type, and then, gatekeeper, and then contract, and how they're all related? Is there maybe something, Hang, you can post in the chat on that, or some more information? Because I think that's a super important model to kind of maintain or have in memory when we're kind of going through this example, because it helps understand the relationships and how things are working.
actually we can see the contract ID is here, and we can try to interact with it. So first we need to put the contract, we try to, the ID of the contract, we try to interact here. And then we need to get the API, pass the API, just like here. The method, I think I can do a simple explanation, because when we try to compile the ink contract, it actually provides two things. The first is the WASM code, is the code. And another thing is such the metadata .json, and actually it's just describe all the interface when you try to interact with the contract. So actually you can pass it here. Okay. Yes, and load the contract. Also, just like before, I need to first sign a certificate for all the following queries. And now we can get the value of the coin. The current is false, and after we have click a flip, the flip is a command just like before, and we need to wait a few seconds for the command to take effect. But actually, we can still keep a query for the state of the contract. Now we can see the change, because all the query just get all the query happens real time. So we can just catch the points when the value of coin just changed.
Yeah, so the Flipper contract is super simple. It's always it's basically it's going to be either true or false based on a coin flip logic, right?
Yeah.
So and it's pretty standard in Ink. It's kind of like the standard tutorial like contract to learn about how to use Ink.
And I think what matters is what happens behind this, because actually we have just migrate all the unmodified contract palette, not the full palette. Actually, we use the core functionality of this palette. So actually, we can just support unmodified ink contracts. So this is just an simple demonstration, but actually we can support even your contract is more complicated. Only if your contract is okay to run for example, in the canvas, I think your contract can be okay to run in our network, and you don't need to change the code of it. Just deploy it just as I have shown. And actually, I think I can do something better. Oh, sorry. I think, for example, I think an important limitation of the current ink contract is that actually, although the current ink contract supports the query, just like we have done, but actually the current ink contract didn't support the access control on the query functionality, because actually there is no meaning to do the access control, because actually in the previous ink contract, all the data are public on the blockchain. So actually, even if you try to do some access control, we can just use a modified client to trick the contract and just overpass the access control. And also, I can just choose to directly read all the sensitive data I think I want from the blockchain. Just do the deserialization, and this can work. But actually, first, in our example, the contract is executed in the secure worker, so its states are totally encrypted. And also, I can show here about we can extend it to add the access control to all the queries. So only the owner of the contract is allowed to read the value of the coin, and when we try to use other accounts to read the value, it will fail. So it's relatively simple. We can just add a field called the min here. Yes, the min means actually it should be we should init it to the value of the contract deployer. Yes, we set the min to the person who just called the constructor of our contract, just the deploy of our contract, and then we can add another here. I think we can add access control here. So here we can check the caller of the get function, and only if she is the min of our contract, we allowed her to read the value. Else we can just return on now. Okay, relatively simple here.
Mm-hmm.
Yes. And we can do the compilation again. Nope. Sorry, I need to record this.
What's your error?
Great. Okay, now we can get we can do all the deployment work again.
Nice.
Here, again we need to first upload the new code. Actually, we can see the size of the WASM has changed a little bit. Okay, we can see the code is uploaded, and then we need to instantiate it again. Also, the same selector. Yes, we still deploy it to the same worker. Wait a second for the instantiation. Okay.
Which account ID did you set it to?
I use Alice to do the instantiation. So I will show that when we try to use the Alice account to do all the, for example, to read the value of the coin, we should get the real value. And if we use another account to try to read the value, it will just get some null results.
It'll be null, or will it handle some sort of error or something?
Because from my code, it will just return a null, just like.
Okay, cool.
Sorry, here, yes. If
right.
he's not our administration, we will return null to him.
Yeah.
Okay. Sorry, I need to check the contract. This is the contract ID I try to interact with, and again. Yes, but we need to reload the metadata because the hash has changed.
Yeah.
Okay. Now I will still sign the certificate from Alice. So in this way we should still able to read the value. Yes, we can still read the value, but actually we can try to switch our accounts. For example, this is another test account for me, and we need to sign the certificate again. And now we can see, yes, it cannot read the value because we changed the access control here.
You're locked out. Yeah.
Yes, you're locked out.
And so, I mean, obviously, you could extend this to whatever you really want to achieve, and have maybe sort of like a set of authorized members that can access this contract, and so long as you are an account within that set, you can access it. And if you're not, you cannot. So yeah. That's actually really cool. I'm trying to lean towards, if I were playing around with this, or if I wanted to implement my own, blockchain idea or whatever, like there's a lot that can be done, right? And I think what you're showing is just kind of a great sort of POC of that, which is super cool.
Yes, actually, and we are very glad to cooperate with the current Ink team. We need to try to cooperate to make such things better. And I think since we can enable the execution of the Ink contract inside secure worker, it can really release the potential of the current Ink contract. And also we have just shown, actually, we can do some simple extension to the current Ink contract capability, because actually we just use all the existing Ink contract features to implement the access control to the current query functionality. This is what we try to present here. And actually, to learn more, yes, I think there is some materials here, and we are trying to provide more for people to understand what's the mechanism of the fast contract and what's the power of it. And for now, I recommend that there is several. First, there is an article here. I think this article, it's just introduce our motivation and the overall features of the fast contract. And actually, I have covered most of this part, but I think it's still I still recommend people to read it to see what motivates us to try to design such a contract which is totally different from the existing one. And also we have I think we have the necessary tutorial for you to just replay all the demonstration I have presented before. You can just refer to our developer guide in our wiki to try to deploy your own native contract here, and use the four features here. And also we have just prepared a tutorial for today's workshop, and you can just use it to try to run your Ink contract inside our workers. And we really expect your feedbacks about it, so we can try to make our contract better. And also I've just presented the link to our developer channel in our Discord, and we are very glad to just communicate with all the developers who is interested in our contract. Also, okay, and I will show the final part I want to cover is about the future roadmap of our contract. And actually, for now we are here, and soon we will try to just deploy the Phala testnet. So I think, and we will enable the contract deployment functionality in our testnet. So actually, anyone, you can just come to our testnet and just deploy your Ink contract, a modified Ink contract to it, and try to play with it and enjoy the benefits of the performance, of the privacy, and of the access control I have just shown. And actually, in the first quarter of the 2022, we will support the fast contract on our mainnet. So actually, you can really deploy some serious logic, serious program in our mainnet. And the last job in the second quarter of the 2022 is that we will cooperate with the Ink team and extend the Ink contract. So in the Ink contract, you can make full use of our features. For example, you can access the HTTP service, access all the internet service from your Ink contract. This is our final target. And I think if we can really achieve this, then the Ink contract will be more powerful than it is now. And I really look forward to it. Okay, I think that's all for my presentation today, and I hope you enjoy it. Thank you.
Awesome. Thanks so much, Sheldon. This was super informative and a very well presented demo. I mean, usually demos go wrong. Yours was very to the point, and nothing went wrong, I think, right?
Yes,
So,
that's great.
yeah. Yeah. I mean, I'm super excited to just going back on the your roadmap, like what's to come with maybe collaborating more with the Ink team at Parity, and they're constantly working hard at improving Ink and extending features and stuff. So it's awesome to see, like, members of the community like you guys that are working really hard at some very specific use case that can be extended to other use cases, right? There was a question that came up but got answered by Hang, but I think for the sake of completion, like, I may as well ask it here. And the question was, is it possible to do computation in a fat contract that is both intensive and private, in the sense that, are you able to do both, like maintain privacy and at the same time intensive computation in Phala?
Yes, and actually, I think we have many potential use cases, and actually, we are already cooperating with some of the projects in our, for example, what's a proof of concept we have just tried is that we try to do the picture rendering, image and video rendering inside our SGX, inside our secure workers, and it can be really done. And I think, for example, the previous such kind of service can be really expensive, and it can be really computation intensive, because yes, it's really take many computation to do all the rendering work. But actually, for example, and actually in our network, we have many workers. I think we have over 10,000 of workers, and we have many computing powers, and we really want to contribute such computing power to our community to do something for our community members. And for example, the current Remark NFT is very popular, and actually all the artists, they need to pay a lot for the rendering of their NFTs. But actually, if we try to provide such services in our network, I think they can just access our service with a very low price. And also, since we are a blockchain, which thanks to the protocol like the XCM provided by the substrate, and we can use the XCM to combine our contract with the Remark network. So actually, all the things can be very simple. You don't need to do all the NFT upload work, because our contract actually can do all this for you. So you just upload your model, and all the things are done.
That's really cool. So this connection with Remark, which it's the second time you're mentioning it, right? You mentioned it first as that some member at a hackathon, I assume, did some sort of prototype using Remark. And I'm kind of seeing, like, really the potential of using fat contracts with Remark. I know that. So by the way, like, those watching, there is a great seminar where Remark, like, what is Remark is presented. And it's basically it started as a graffiti on Kusama that really is translated into NFTs, but NFTs done in a way that no such NFT is currently created like this. And the TLDR is that it's very lightweight, but it has a lot of capabilities. And so basically, you can sort of conditionally render things. You can have NFTs that get rendered based on what the browser has as like what's working in the backend. So for example, if it's like a very sophisticated NFT and the browser is not really compatible with it, it'll still render, but like just a 2D version. But if it's if the browser has the sort of backend to power the full experience of that NFT, you could have something like Phala fat contracts working in the back rendering that NFT. And so I definitely see the power of that. That's really cool. Is there any other like other use cases and stuff that you're particularly excited about?
Yes, actually there are someone who is very enthusiastic, because actually they try to ask, they just come and ask, can I run my for example, the AI model training, and the AI model, I think justification, for example, such kind of computation in your network, it is possible. And actually, I think we are using a project called the Graphene, and currently it should be called remind. And I think most of the demonstration of this project is the first is the rendering work, and the second is the AI modeling running work. And I think such kind of work they can both so actually Phala can both support such kind of calculations. And again, I think what we do is that we just broke a limitation of the contract. So just we hope all the developers to use their best imaginations to try. Actually, you can do anything you currently do with the traditional cloud service. For example, when you use the AWS, when you use the Amazon, use the Alibaba, the Alibaba or the other kind of clouds. Actually, you can try to do such things on our network. So that's the great part.
That's awesome. We actually had a question come in. Laurent is asking, is or will the side task feature be available in Pink contract?
For now, it's still not available in contract, but we really have the plan, and we are really working very hard to try to extend the in contract to support the side task.
Awesome. Cool. And so I guess my last kind of questions, and maybe to wrap up, is like from your perspective, what's the best way for developers out there to really get started? Maybe there's some of us here that are just learning about Phala and their use of ink and fat contracts. Maybe there's some of us that are more experienced and have maybe more of a handle with developing with ink. Where's the best place to get started, and any pointers for developers like excited about building with your technologies?
The first I will recommend is that please, we really welcome all of you to join our Discord channels. And we have a developer channels, so we can just discuss. And if you want to know all the information, we will try to share. But actually, I think we can respond a little slow because we are really short of hand here. And also, Han has prepared the first for the previous hackathon. We already have the tutorial for the native contract, and today Han has just finished a tutorial, a very detailed walkthrough of all the contract deployments and I think the link is already available in my point. And also you can just search for the Fat Contract Workshop in the GitHub, and you should see the repository, and you can just follow all the tutorial and just play with it.
Cool, super cool. Yeah, so if you don't mind sharing the link to the slides so that other people can access, the material that you went over today, that would be great.
Yes, I'm totally okay with it. A second.
Super cool. And I guess while you're doing that, is there any last things you want to say to those watching and sort of developers here in the Substrate community?
So we just very welcome for anyone, for all people to just try to use our contract, try it, and give us feedback to make it better. So that's I want to say today. Thanks.
Cool. Awesome. Well, thank you so much, Selvin. This has been super great to have you on seminar, and I wish you a great rest of your evening.
Yeah.
And
thank you.
For those watching, you have a great day or night wherever you are. We'll see you soon. Bye.
See you soon. Bye-bye.